body experiences SHM at a rate of 10 oscillations per minute with an amplitude of 4 centimeters. So it's worth noting that here we're working in centimeters and minutes. Find an expression for the displacement x of the body from a fixed point O at time t if the body starts from x equals 0, so that's the mean position, initially travelling in the positive direction. So what we've got, if these are the extremes, and this is the mean position here, that it starts here and it's travelling this way. Now generally x is going to be a sine nt plus some constant k. Now the fact that we start here when t is 0 tells us that k is 0, because remember sine of 0 is 0. So we've got that k is equal to 0. The amplitude is 4, so that tells me that a is 4. It could be negative 4, but initially we're travelling in the positive direction. And if we think about v here, v would be an cos nt plus k. So if t is 0, then remember the k is 0, we've already worked that out. If t is 0, cos is 1, and therefore if a is positive it will be travelling in the positive direction. So we know it's 4 and not negative 4. So we've found k, we've found 4. Now remember that the period is always 2 pi over n. Now here we're told the period is 10, so that's going to be 2 pi over n. So 10n equals 2 pi, giving me that n is 2 pi by 10 or pi by 5. So we've got all of the constants we need. So it's going to be 4 sine pi by 5 t. Now it's starting at x equals 4. Now we don't need to worry about the direction of travel because it's actually going to have a velocity of 0 if it's at the extreme point here. Now if we start off with x is a sine nt plus k, a is either going to be 4 or it's going to be negative 4. And I'm pretty confident that it's actually going to be 4, because if we think about the sign goes out to 1, which means x goes out to 4, and then it will start to come back again, but it's still positive. So that's going to be 4, so a is going to be 4. The n won't have changed, like so. So we just need the k. Now remember, one oscillation for a sine, that's a sine without an n here, is going to go from 0, this is pi, this is 2 pi, so pi by 2 and 3 pi by 2. So when t is 0, we need the k here to be pi by 2, so that we're out here. Sine of pi by 2 is 1. So k is going to be pi by 2. And so we can now say that x is going to be 4 sine pi by 5t plus pi by 2. But of course we know this relationship with the sine, that if we move it by pi by 2 it becomes a cos. So 4 cos pi by 5t. Now x is 1, travelling initially in the negative direction. So this is the line we're moving along. we're going to start here so that this is 1, but it's going to be moving in this direction. Now, still we're going to have this form, and some things won't change. The amplitude is still 4, so that's 4. It could be -4, so we'll just leave a little gap there. The end's not going to change, and then we're going to worry about the constant in a moment, and that's going to do with the starting position. Now if we were to differentiate that, the velocity would be 4 pi by 5 cos pi by 5 t plus a constant. Now what we can say with this constant is it's going to be an acute angle, and it will either be positive or negative, so we'll have plus something or minus something here. Now this is the A quadrant, this is the C quadrant, so whichever, when t is 0, the cosine itself will be positive, but we know we're travelling in the negative direction. So that tells us that this has to be a -4. Now if t is equal to 0, we need -4 sine k, remember this part would be 0, to be equal to +1. So sine k must be -1/4. So k is going to be the inverse sine of -1/4. Now we're not going to get that as an exact value, so decimal is fine. So we want inverse sine of -1/4. That gives me I'll call that 0.253. We'll go to 3 decimal places. So we can now say that x is -4 sine pi by 5t, take away 0.253. And that will get us starting at the right place and moving in the right direction.